Alright, so this is number 25. I hope this is the one you guys wanted. And I did like a long explanation. I hope that's okay. If it's not okay, then it's here anyway. So, alright. So, the question asks us to predict the base peak for 2-methyl propane, right? So here we have the molecule. It's been ionized, and the electron is most likely going to be lost on the chlorine atom because it has a bunch of loose, unbonded electrons. So the mass to charge of the unfragmented molecule is 92, and that's with chlorine 35, not 37. So then the what's it called? The things that they give us, the choices that they give us is mass to charge ratio. The base peak is the most abundant. What is the most likely fragmentation of this molecule? So if it's MZ15, that means that there's a positive methyl group that left, right? Because 12 plus 3 is 15. If it's MZ92, that means it never fragmented, right? So it just stayed like this and it never fragmented, which is always a possibility. No fragmentation. And again, that's only if it has the Cl35. Then there's MZ43. So with that, a methyl group, a neutral methyl radical and a neutral chlorine radical would have to leave, leaving behind the propyl group, propane by itself. And it's 43 only with carbon 13, which all these other ones were using carbon 12, but all of a sudden carbon 13. You need carbon 13 to make it 43 because otherwise you have 12 times 12. 12 plus 12 plus 12 is 36. 9, 6, 7, 6, 3, 6, 9, 36 plus 9 is, oh no, it's just 36 plus 6 is 42. So you need the carbon 13 in order to make it 43. They give us MZ57, which is a loss of chlorine, right? Leaving behind a chlorine neutral radical, leaving behind the methyl group, the propyl ion, and the methyl group. So this would be the fragment that's left behind. When you count all these up, it's 57. When you count everything up, it's 57. And then the last one is mass over charge 77. And in order to get that, that's a loss of a neutral methyl radical, right? So we want to figure out which one of these mechanisms is the most likely to happen. So first there's MZ15, right? So we said that would mean a positive, that's a positive methyl group. So that a positive methyl group would have broken off and left us with the neutral, this neutral molecule right here. So in order for that to happen, we would need the methyl group here would have to donate both of its protons to the bond and then one of those one of those electrons to the bond, and then one of those electrons would come up here to the chlorine. That was, that was positive. And then it would leave as a positive, and this would become a neutral radical. But that's not very likely to happen because that would be a first degree carbocation, carbocation, and that's not the most stable thing that we can get, right? Alright, let's see if I can make it. Okay. So then there's MZ92. That's no fragmentation, nothing left. The molecule just stayed like this after it was ionized and the electron got taken away from the chlorine atom. It just stayed there. But since electronegative chlorine, okay, chlorine's very electronegative, so I think my theory is that it's likely to take electrons. It's more likely to take electrons away with it than to just sit there and do nothing. That's all I can say why it wouldn't be that. MZ equals 43. So that means we loss of a Cl. Okay, that would mean, okay, so we would lose a, if it was 43, we'd have to lose a chlorine 35 neutral radical plus a neutral methyl radical. Okay, so that's not likely to happen. Not likely to happen because would change a third degree carbocation to a less stable second degree carbocation. I know we say this has to be the positive particle. That's why it's being picked up, 43, and you get 43 if you subtract, if the total ion weight, the total mass to charge weight of the unfragmented ion is 92. So when you subtract 35 and 15, you get 43. That's how we deduce that this is what you would have to lose in order to get this. So the mechanism to make that happen is unlikely because, so first we'd have to have this, we have the chlorine. The chlorine would have to take 2 electrons with it, which that's pretty likely to happen. And that would leave behind a third degree carbocation like this, plus the neutral chlorine radical. But then in order to get rid of the methyl, we also need to get rid of a methyl to go down to 43. This would have to take 1 with it, one electron with it, and give 1 electron to the bond to the down here to the carbocation. You can't quench a carbocation or a positive charge unless you give 2 electrons. And then that would come down, so then the methyl group would break off as a neutral radical, and you would have the second degree carbocation with that extra electron floating around. Now that's not likely to happen because it would turn, this was a third degree carbocation, right? That's not likely to happen because it would turn the third degree into a less stable second degree carbocation. So then 57, mass to charge 57, is the loss of a chlorine 35 atom. 92 minus 35 equals 57. So chlorine is most electronegative and likely to take 2 electrons with it and would create a third degree carbocation when it left, right? So the mechanism for that would be like this, and it would take 2 electrons away with it, splitting off, leaving a tertiary carbocation, the most stable, plus the chlorine radical, neutral radical. So that's the most likely out of everything that we've seen so far to happen. And then in order for MZ to happen, MZ 77, we'd have to lose a neutral methyl radical. We can deduce that because 92 minus 15 equals 77. And the mechanism for that to happen would be something like this. Right, so here it is. What would happen, this bond, one electron would have to come up to the methyl group. 1 electron would come down here to this bond, and then I would think 1 electron would come up here to the chlorine, and that's kind of feasible because I believe that it would create a tertiary carbocation, a tertiary carbocation, and then plus this neutral methyl radical. But Cl is more electronegative and more likely to leave with 2 electrons. And that's what I'm assuming. Okay, that's my assumption on it. So that's why 57 is the best answer.